All right, I think we're live. Good morning, good afternoon, and good evening to all of you watching. Thanks for joining us on our August live code today. I'm Anish Bhargav, and I'm joined by Ganga Sumanth, Associate Security Engineer at AppSecEngineer. This is his first live code of many, so be nice, okay, folks? If you have any questions, feel free to just drop a comment. We'll try to answer as many questions as possible. By the way, everything you're watching on this live stream is from our GoLang Security Playgrounds, a hands-on course where you learn secure coding practices specifically for GoLang. Now, Ganga, as you know, I'm not really a technical person. I'm more on the marketing side of things. So, what exactly are we learning today?
Thanks, Anish. So, as to what we're learning today, Go as an application, Go as a language is built quite built in a way to make it quite easy for people to approach it. If you're trying to build anything for the web server part of things, and it occurs to me that sometimes there are a few um, easy but big potholes that we sort of miss in this development process. And our course that you just mentioned is something that dives into such topics and tries to help you shore up such skills. So this session in particular is going to be a deep dive into what you could avoid if you want to avoid cross-site scripting attacks or CSRF attacks on your application. I will be showing you where you could be going wrong, what sort of attacks can happen, where the vulnerabilities lie, and what you can do to defend against them. So this is just going to be a short session about how this works, and I will be showing you your code as well.
Okay, great. So, I'm guessing you're going to be showcasing something like hands-on, right? So that we can, get a better idea of how it works.
Definitely, hands-on labs are our biggest selling point here, and I will be showing you how I will be breaking down the code for you and showing you where you could be going wrong, where you should be doing it properly as well.
Okay, great. So I think you can get started and I'll get out of your way. By the way, folks, if you have any questions, please drop them in the comments and we'll try to answer as many of them as possible. Okay?
Thanks, Anish. Well, jumping straight in, I suppose. This is a small part of our larger course on Golang security, and we cover many more topics there. But focusing on the ones right in front of us right now, cross-site scripting and CSRF, I will be taking you through the fundamentals of each of these concepts and how they could be affecting your application and what you could do without using any fancy techniques. But like the Golang packages itself have a very comprehensive way to shore up your defenses against something like this. And I will also be talking about a couple of frameworks that could help you in your journey to make it a much more easier experience, and obviously they're less prone to human error if you have a framework that is like sort of looking out for you. Moving on ahead, well, let's start with cross-site scripting. And although the name sort of is dated at this point because cross-site scripting was the title given to it in the early 2000s when such a thing was sort of possible. But right now, we should probably call it script injection, or more aptly JavaScript injection, because everything seems to be running on JavaScript these days. Every website that you see is going to be running JavaScript in one or the other forms. And the idea here is that in case your browser is unaware that the JavaScript that is being served to it from a web server is not authentic or is malicious, your browser does not know that, and it is going to execute the code given to it and thereby lead to some very interesting or, well, bad effects, let's call them. So, I just mentioned something about how this was no longer possible, and let me dive into something that's called same origin policy that was defined to stop this from happening. Same origin policy is trying to make sure that websites from different domains with different protocols that are that are handling them are not trying to get into each other's spaces and trying to attack them and take their information, or just hit every endpoint that you can and scrape out the data from there, or run malicious scripts that could in turn lead to some very bad things. So how does it How does same origin policy work? Well, it's pretty simple. It is going to look at the URL or the request and response protocols, and it is going to look for three things: one, the scheme; two, the host name; and three, the port number with which you're accessing these particular requests and responses. If any of them are dissimilar from each other, your same origin policy decrees that your application is not allowed to write or read in using those scripts on your vulnerable application. So in this case, we have attacker.com, which is making requests to another application that's called vulnerable application. In case same origin policy was not there to enforce this, same origin policy, by the way, is something that runs on all of our browsers by default. And this is just going to allow the scripts to not talk to other websites and cause problems afterwards. So moving forward. So what exactly is cross-site scripting and how does it happen? Well, let us talk about the baseline. Let us say you have a browser that is talking to a server. What we expect for it to happen is, in case I was to make a GET request and let us say I'm posting to a server, it's a very simple comment section that I'm posting to the server. I expect a response wherein it says whatever I've given it is being reflected back to me, and I expect it to be in a HTML encoded space so that my browser can render it onto a web page. However, instead of making the innocuous little comment that I'm supposed to, what if I were to input something that looks like this, something that says script, and I'm making alerts, or maybe I'm trying to access some document, something through the DOM, the document object module, or maybe I'm trying to access some parts of the internal server itself, or maybe I'm trying to redirect my user towards another web page altogether. So these are the things that could happen if you're not looking out for inputs such as these. So by default, the browser is a very trusting individual, and any sort of HTML or JavaScript that it is served with, it immediately renders onto your browser page. And this is because the browser implicitly trusts the server to give it information that it is expecting and not to something outside of the ordinary. This is the point of trust that cross-site scripting is taking advantage of. Okay, so we've talked about cross-site scripting. Obviously, there are probably multiple types of it. So let's dive into them. The first is reflected XSS or reflected cross-site scripting. I will show you what that is. There's also stored cross-site scripting, and there is DOM-based cross-site scripting. So in case of reflected cross-site scripting, the attacker is able to craft some sort of a malicious URL wherein he is inputting extra information. Maybe he is going to uh, give you a redirect page, or maybe the HTML uh, request that you're supposed to make of the server is somehow changed in order to in order to retrieve a response from the server that is not intended by the developer. So a bad URL, or maybe there's an already pre-crafted post request that is hidden behind something. Maybe you have an image link that has a post button behind it, but you can't see it. Maybe you have transaction information being tampered by a bad actor, and when you click on it through your authenticated browser, you're going to make a request to the server without knowing what you're doing, or without being aware that you're doing this, that you're making a request that you would seemingly thought was innocuous, but it isn't. The server, if it is not ready for such a thing, is going to look at the request made by the browser and look at the user, say, okay, this is an authenticated user. He's making a request, so it is going to serve the request without doing the correct kind of escaping, looking for the correct sort of URL tags, or maybe JavaScript attributes or CSS attributes that could go downstream and pollute your applications further on, and the experience that your user has with the application. So the response that is given back to the browser is going to contain the malicious data that was initially introduced by the attacker. Why is that bad? Well, We'll come to the impact in a second, but let's just talk about cross-site scripting. This, as you could possibly imagine, stored cross-site scripting goes one step further, and instead of looking at one single individual, one browser that could be perhaps focused upon by using social engineering. You make your user click on a link that they're not supposed to. You keep a browser tab open on a library and people just come and type their information there. There are multiple ways to do it, but in case of stored cross-site scripting, you're going one step further and you're sending the malicious code directly into the database. So the server, the web application server, is going to accept your user inputs and somehow store them into the database without expecting that this could be somehow bad. So, for example, let us say you're creating a login, registering yourself with an application, and it asks you for your login details. Let's say it says, I want your username, I want your password, I also want something like a secret question answer sort of paradigm. And in the place where you're supposed to be putting up your answer, let us say you go ahead and you inject an entire new web page in there. And that this is encapsulated correctly in HTML, but the server is unable to understand that it is supposed to expect only one or two lines or maybe a phrase at best, but it goes on and receives an entire page. In that case, the next time any other user comes across something like this, comes across a page where they're resetting their password, like they say, and instead of looking for the user, the secret question and password paradigm, it comes across this page which is served to all of the users from that point forward. So even if the browser is making innocent requests, they are immediately met with responses that have been already tampered with previously, and you're going to be rendering data to a browser that is going to simply accept it. The user is having an experience that he's not supposed to, and there's a lot of scope for advantage being taken in this scenario. I haven't touched upon DOM based cross site scripting, but in general, what you're going to be doing there is you are able to inject code, JavaScript code, directly into your document object module. You're able to retrieve information from your browser, and maybe you're even able to write to the browser's inner diff functions, and maybe you're able to link to another website, or maybe you're able to like extract the information of what that browser is supposed to be doing. You can use this to, let us say, spy on somebody. You can look at object the user's actions from that point forward. So obviously cross-site scripting is not the best of things. And what can we expect from something of this sort? Well, A, if your browser, which is authenticated with your server, is being forced to send requests that the user is not intending, then account impersonation is a very easy thing to do through cross-site scripting. Generally, I think the example that all of us run through is in case you have a banking application and you want to create a request wherein you are transferring money. You have a post request, for example, and that says from account A to account B, please transfer $100. You end up being able to use cross-site scripting to change the attributes and say instead of sending it to Bob, you send it to me instead. And suddenly you have a transaction that was not intended, but you're able to complete it and break the application thereby. You can use it to observe user behavior, like I just mentioned before. You can load external content. This is a beautiful one, and I will be showcasing this in the lab in a few minutes. So let me talk about it then. And you can also steal sensitive data. Like I said previously, if you are able to uh, change the user parameters, maybe you can go ahead and serve them a web page where you're asking for credentials, but the application itself is not looking for something like that. You can connect your response from that particular request to a server that the malicious user wants. Like your attacker is able to get this information from that form and then pass it on back to the web application, and it doesn't know that this transaction has occurred. Okay, so we have we have established that process scripting is a bad thing, but how do we fight against something like this? Like, obviously, it's been around for a while. So, in general, what we do is we ensure that we're using the correct attributes. And anytime you're trying to escape sequences, escape if you're trying to execute templates, and if you're trying to write to the HTML parser uh, that is going to serve your content to your user, you ensure that there is always a layer of escaping data sanitization, input validation, and output encoding. There are methods in which you ensure that the uh, the data that you're accepting into your server and then sending back out into the template into the browser are always going to be clean. You're going to be making sure that you use, for example, use set attribute methods which automatically do HTML attribute encoding. Then you use quotation marks in your variables to ensure that you're not exposing it in such a way that your attacker is able to then insert his own code into that div that you've left out. You always ensure to use the escape function, which does hexadecimal encoding, and you do HTML sanitization, which will always strip your dangerous HTML from variables and then return a safe string of a HTML. Okay. The first thing that I've put up here is called framework security, and it ensures that the framework security is generally a good idea because frameworks such as in the scope of GoLang, you have things like Echo or etc. The idea being the framework already lays down basic principles for how you're supposed to be building, and it reminds you if you have vulnerable areas, and it ensures that in most cases they're always covered up within the framework itself without the developer having to uh, individually go and address every single breaking point. Like I said, variable validation and sanitization is also going to go a long way, and output encoding is going to ensure that what your server is spitting out is also going to be as clean as possible. Okay, so at this point we've come to the code lab session, and let me just showcase one of the labs that show you what we're talking about. Okay, so what we're going to be looking at right now is some Go code, and this is very straightforward Go code. It is going to be creating a server and serving a couple of web pages. The idea here being that I'm going to be handling two functions. One is called unsafe parsed, and the other is called safe parsed. And these two endpoints are going to serve as the two examples that I want to showcase. One where you're not doing the correct sort of data sanitization, your input validation is not happening here. And it is going to be reflecting the same input back to the user. And that is going to be causing a cross-site scripting in this problem. Uh, in order to show you what I'm talking about, I'm just going to show you what the um, web page will look like if I were to just run it. So this is the index page wherein I'm expecting a comment to be put into this text box, and I can either post it, I can create a post request that either sanitizes my inputs properly and then reflects it back to me, or it does it unsafely. So my output page is it's going to be using a very straightforward templating engine. Excuse me. And the rendered output is going to just follow wherever these the dot operators are staying, and it will just reflect the same answer back to me. So going back to our code, anything else I can show you right now? It's a very standard sort of application code where it is serving a couple of web pages. I think it will make a lot of sense if I were to just run it once and then we can come back to seeing what the difference could be. So let me just start up a terminal here, and looks like we already have the correct deal. But let's just go ahead and build the application to make sure it is on the latest, using all of the latest changes. Then we run it. Okay, looks like it is running on this particular endpoint. So as I said, we expect this comment section to just reflect it back to us. So let us say something like, hello there. If I were to post this, I'm going to be receiving a response which is the exact same as what I've done before. Similarly, if I were to post it using the other uh, submit option, the other endpoint that I'm submitting to, it is also going to do the same thing. So from a user point of view, they're very similar, except one of them is not going to be looking for a possibility where I could be doing something malicious. So let us try everyone's favorite little thing, and I just create an alert that is going to drop a small, so it's just a small JavaScript line that's going to create an alert in case there is not the proper escaping happening. So if you see the save method, it is simply going to reflect it back to me, which means it is doing the correct sort of escaping and it is treating all of this as text. And in no part of the process, when it goes from the application, from the browser to the web server, is it being treated as special characters. But if I were to do this using the other method, suddenly we notice that it is being parsed not as text, but as HTML code, as JavaScript code, and the escape thing is not working as intended. So we have a vulnerability. That much is for sure. But what do we do with this information? Like, can we exploit it further? Can we do something interesting with it? Okay. So I have another little bit of code for you, and let me just open this. So what I've done is I've created a small web page that is going to look very much similar to the web page that we were accessing before. And what I'm going to try to do is I will try to insert this into that into the previously filled web page, and it should reflect this back to me if what I think is correct. So let us try it. And there you go. As you can see, we have a this is completely unintentional, right? The developer does not want you to type your username and password when you're trying to type in your comments. And in this case, if I were to do something like Joe Bob and type, I don't know, my password, which clearly this information is being posted to the server and being reflected back, which means this form is no longer going to be secure. In this case, I have not done anything particularly malicious. I've only created an alert that says, okay, show it back to me. But if I were to go a step further, I could start up a server on a different port or on a different web page and simply redirect all of this information back to that. I could set up a post, I could set up a server there and receive this information, and I'd suddenly have the credentials to follow this core users. In the context of that, let me just show you what I was doing here. I simply had a small function, a script that was going to say, in case you find an element with this email input value, pop up an alert. But instead of popping up an alert, I could simply use the submit button. And in this case, we're not posting anywhere, but I could have the form action that says, yeah, right now you see the form action is empty. But I could have a form action that says post to a particular endpoint. And that's it. The credentials are now being posted to an external entity. So this much is apparent, but what was the difference? Sorry, I had stopped the server, but Let me just show you that it is not going to work in case I do the same thing, but I use the safe method instead. As you can see, the entire input is being reflected back as text, which is as intended. But what was the difference here? Like, why was it not uh, being reflected back as rendered JavaScript instead of just being text again? So the answer lies within the Go page, within the application code itself. If you were to see, let me just see if I can just get this to the right. Yeah. So we have safe cast and unsafe cast. If you see the difference here, it's actually very small. It says it's in this line here. What we're doing is we're executing a template named P, and we're writing something to the response writer, which is being executed as HTML code. This is obviously the worst possible thing. And in this case, if you were to see it, it explicitly mentions that this particular method is only to be used in case you have a known safe HTML document fragment, which I clearly don't. But in the case of a safely passed thing, you simply execute the template and that's it. Why? Why? Because you have something called the HTML slash template package that is served directly through Go. And if I were to click on this, in a sec, let me just go to the page. So this is the package that we are using right now, and to give you a small uh, insight into what this is trying to do, this is actually built atop of the text slash template package, and text slash template is simply a template rendering engine, and it gives you various methods to write to a template. It lets you like range over from a set of, maybe if you have like an array that you want to render to a template, text slash template can do that for you. HTML slash template is only a small addition on top of that, which is specifically for any sort of HTML elements. What it can do is that it can look for HTML template reads data values such as plain text, such which could be encoded, and they are safely embedded into an HTML document. And the escaping that is provided to you is contextual. So if you have JavaScript code, you have CSS code, or you have UI context, any of these things uh, within your inputs, then HTML first template is your friend. It does all of the work for you, and it does the escaping, and it does the data sanitization, it does the variable validation, and therefore your output is going to look like text. So always use HTML slash template. Don't use text slash template, which is actually the default. If you start writing, if you start using the template method, your import is going to automatically bring out text slash template. But in case you require HTML slash template, which you almost definitely do, if you're writing any sort of a HTML web serving application, make sure to use this. All right. So moving forward, uh, let us talk about CSRF, which is cross-site request forgery, and this is not so much of a problem anymore these days, but it's still possible. There are certain elements that are still vulnerable to it. Like for example, if you have Adobe Flash, it for some reason does not follow uh, same origin policy, or if you are able to set up redirects in a particular way, you are still able to exploit CSRF, wherein the the web server is not aware if the request is coming from an authenticated user or it's coming from somewhere else. So, what is CSRF and how does it happen? Well, very ideally speaking, when you set up an application, you are expecting your endpoints to be the only ones that hit your internal resources. So, for example, you have a login page. Your login page is going to be the only one that is going to be serving requests. I mean, making requests to your endpoint. However, there is a possibility that somebody else could craft a form that is able to replicate the request that you're looking for, and it hits your API endpoint, or it hits your defined endpoint, and it then starts a process wherein your server is going to continue to do its actions that you've defined, but the request was not made to a legitimate source. So in this example, let us say a request to make a delete uh, request is made, but your application server is just going to think that is a legitimate request, but your user was unfortunately clicking on something like cat.com, and suddenly he realizes that there was a post request made without him being aware, and now he's lost his account on your application. So what could possibly go wrong if if you're vulnerable to CSRF attacks? Well, if you're if you're vulnerable to them, like I just said, you could have delete requests being made without you being aware of them, or you could have maybe email changes. You could have possibilities of somebody creating requests from an endpoint that is completely foreign to you, and you will still accept them as if they're coming from the user that you were expecting them to be. Good. So, okay, so we've discussed how CSR can happen, and well, let us talk about the defenses that we can put up against such attacks. Well, to start with, we make sure we always add CS. Okay, there's a concept called CSRF tokens, which are quite ubiquitous today. And the idea is that you authenticate your user's browser with something called a CSRF token that is going to be a randomly generated long string that your server as well as your client have a copy of. So the moment your user is making the request through his browser, you expect that the request also comes with the CSRF token. And once you validate this token, you are then aware that the request is being made from a legitimate source. Obviously, you should not be transmitting your CSRF tokens on your GET requests, which are publicly available. They should not be put into your cookies, which are visible on browser history, or if you're pulling out logs. But yeah, in general, framework level security is the easiest way to go about this because you have CSRF tokens or CSRF built into many application level frameworks. For example, you have Echo, which gives you CSRF, um, which gives you CSRF protection out of the box. And obviously, if you're making any sort of state changing operations, if you are asking your user to delete their account, or if you're asking them to change their email IDs, definitely use post requests because you're not that sort of transaction should not happen on get, which is completely visible on all levels. And you could use something called double submitted cookies. The idea here is you create a token, and then you share the token in two forms. One, you make it as a signature, a CSRF secret, and then you also make a CSRF token. One of which is going to be given to your client as a token, as a cookie, and the other it is going to be reflected back to you in a request, in a GET request or a POST request that your client is making to you, and now you are able to authenticate that the user is who they are because you have a cookie and a CSRF token and a secret, which is signed by your server and then can be decoded afterwards. You can use something like HMAC obviously to make it uh, much less intensive than if you were to use something more intensive. Okay, so that's the lot of talking. Let us go back to our code lab and see how we can implement this. Let me just close this and open up a little code sequence for you. So as is very apparent right now, we're using something called Echo. Echo is a very lightweight framework that is available for GoLang, and it gives you a lot of features out of the box that make it extremely easy for building applications. I recommend this quite a bit. Um, but what we're trying to do here is we're trying to make a web server that is going to use uh, our CSRF as a medium to ensure that you're not being hit by endpoints that you don't want to. But first, I'm going to showcase the unsafe version of this. So what we have here is a very straightforward. We're starting a server on the port 9090, and we are serving two endpoints. So one is just an index file, and the other one is called post form. So which is when I click the submit button, it's going to end up there. Um, Let me just start off this application real quickly. So if I were to just go to build, I will continue the application, and let me just run that. There we go. Echo is serving on this particular page. So we open that up, and what we have here is a small example piece of like login information. This is not connected to any database, but I'm just going to show you how the same endpoint can be hit from an unexpected source. So in this case, let's just say admin password. It's obviously that's the easiest way to do this. Um, all this application is going to do is it's going to reflect back what this particular endpoint is seeing. So right now, my server that is serving on 9090 is seeing the admin and password that I just entered and is being deflected back to us. So what if the same request could be created by some other platform, another endpoint that you don't expect of it? So for this, let me just start another section. Okay, so what I have here is an extremely basic program. All it is going to do is it's going to start a server, and the server is going to be available on this particular port 9999, and it is going to render a template wherein it is going to create a web page that is just put here. Let me just show you what that page looks like. So yeah, this is your classic, your phishing email sort of a thing. It's going to be telling you that you won $10,000. Just enter your username password. Don't think about it too much. We'll get you that money real quick. So let me just service that page. So okay, so let's just say go run Apple. Oh, and as you can see, it is being served on a different port, and technically it's a whole new web page that your original server is not supposed to be aware of. So here, let me say Bob is my username, and my password is Joe Bob. And if I were to post this, you will note that the port that I'm posting to and the endpoint that I'm posting to is from the original server. And I can prove that if I were to go down here, I've just created this post request. I'm able to hit an endpoint that I should have no business hitting. So that's a huge security flaw, to be honest. So how do we, you know, walk through this? How do we get away from something like this? And before I run too far into this, I also want to say like the impact could be that you could have an application page, a web page like this being served to a vulnerable uh, user, an innocent user, wherein they use their credentials to log into an application, and that session can then be hijacked and taken over by somebody else. This could be the start of a long chain of attacks. But yeah, um, let me just tear this down, and instead of using this version, let me give you a more secure version, which I have already built, luckily. And I want you to look at this right here. This is the small piece of code that is going to change everything. So what we're doing is we're introducing a middleware called CSRF with config or CSRF, and it is going to be looking for a hidden field in your form that is going to be called CSRF. And if I go back to my safe.html page, there is going to be CSRF tokens that are handled by something called this hidden value, this hidden input type. So definitely one thing, you do not want to be putting your CSRF tokens in the cookies, which are always shared automatically, and you could just bypass this whole thing if you were to do that. Make sure to use either your request headers or something like an input field on your forms that ensures that your CSRF transactions are being handled appropriately. But going back, if I were to show you the page again, what I'm going to do differently this time, as opposed to previously, is that I am going to be using something called CSRF value, and every time an endpoint is hit, I'm going to retrieve that value from my context, and that CSRF token is going to be used as an authenticating medium to ensure that the endpoint is being hit by a proper user or an authenticated browser, for example. So it's the same thing again here. We create the token and then we make sure it's always testing for it. And then we just build the application again and then run it. See this, those are previous versions, and let me just show you that it's working as intended. So yeah, it's working as intended. Now if I were to go back to my original page, this the hacker.co, the server that I created to create a fake, a duplicate endpoint is still running. So if I were to go back to this endpoint, and if I were to say something like to the uh, it fails. It fails because our serving endpoint, our echo.co, is not going to let that happen. If you see here, yeah. Anyway, the idea being that endpoint is no longer accessible to a port to a form that does not have a required CSRF token. So if I were to show you this post form data, go back to inspect element, application data, cookies, and here you go. A CSRF value is being encoded onto every single request from this point onwards because we're using the correct middleware. If we were to not use this would not be visible. I will try to show you the previous example again, but the idea is this is a token value that cannot be created extrinsically without being aware of how this value is being created, right? So obviously, if you were to think a little further on this, you could somehow duplicate this. If you knew how this value was being created, you could somehow generate this on your own. So clearly, you want to make sure uh, that the framework that you're using, in our case Echo, is handling the pseudo random number generation in the correct fashion. But by and large, using a random generator, a random number like this that cannot be duplicated, because if you go back and look at my this is the hacker.co page and this is the web page, the HTML page that I'm creating here. You see, I've tried to input the values called CSRF and CSRF token, but there's no way I can come up with the value that the server creates at the time of request creation. When a user is coming and talking to that server, when that request is being generated, only and only then do you have the random number being generated, and that number is being shared with your user, and only that transaction is being authenticated continuously using that particular uh, random number. So CSRF tokens are obviously a great way to, um, like break up the flow, so to speak. So ideally, you would always want to make sure that you are creating. your CSRF tokens using a reliable pseudo-random number generator, because that is going to be the next point of failure. However, the other thing to really take care of here, I mean, to think about here is how long do you think your session is going to be? So you can use some parameters to make sure you have a viable length for your random token being generated, but that it also makes sure that you're not expending too many resources either decoding it or encrypting it. Generally, what we try to do is we use something like a HMAC key, wherein you have a server secret that makes it a lot easier to decrypt the token that is being created. And yeah, I think that's it for this session. So we've spoken about cross-site scripting, and we've spoken about CSRF and how we can avoid both of them. So this is a short look at what we have available on application security with respect to Golang. And I think Anish can tell us a little more about that because he's here right
Yeah,
now.
thanks, Ganga. By the way, all of these exploits that you saw from our Golang security playgrounds, where you actually learn hands-on secure coding practices specifically for Golang. We've also got playgrounds for Java, Python, Angular, and Node.js. So thank you so much, Ganga, for providing this amazing presentation. And thank you so much to our viewers for joining this live session. We can't wait to see you next month. See you then. Bye.
Bye bye. Thanks for having me.